In this lecture, we will learn about the quicksort and how to implement it in Python. The quicksort uses a concept called a partition or pivot. We start out by selecting an element as the pivot. The large collection is split into two parts, with the pivot as the divider. Any elements smaller than the pivot come before it, and any elements greater than the pivot come after it. Quicksort is efficient for large datasets, but is considered to be an unstable sorting algorithm, since it may sort items that were already sorted. There are several ways that we can pick the pivot to use in quicksort. We can choose the first element as the pivot. We can choose the last element as the pivot. We can choose a random element as the pivot. And we can choose the median element as the pivot. Let's look at a conceptual example of quicksort so that we understand how it works before we write the code for its implementation. We will start out with the following example collection. Let's choose the last element as our pivot. The last element in our collection is 3, so the pivot value is 3. We now divide the main collection into two sub-collections. To the left come anything less than the pivot. To the right come anything greater than the pivot. So any number less than 3 will be put in the left sub-collection. Any number greater than 3 will be put in the right sub-collection. For the left collection, 1 becomes the new pivot since it is the last element. For the right collection, 6 becomes the new pivot. Now we split those two collections into a left and right collection around their pivot values. Then 6 becomes the pivot of the left collection, and 8 becomes the pivot of the right collection. Once this pass occurs, the list is sorted in order. Now that we have a conceptual understanding of what the quicksort algorithm does, let's implement it in Python. Quicksort works based on a partition, as we just saw in the example above, so we will break our program into two parts, the partition code and the quicksort code. Our first function will be named partition and will take in 3 parameters, the list of elements, a left index, and a right index. The parameters will be named elements, left, and right respectively. Inside of this function we will have a variable named pivot that we set equal to elements at index left. Then we will have a variable named low that we will set equal to left plus 1. After that we will have a variable named high that we set equal to right. Next we will have a while loop that will be while true. Note that we are intentionally causing an infinite loop here, so it will be up to us to break out of it once the proper condition is met. Nested inside of this while loop, we will have another while loop that will execute while low is less than or equal to high, and elements at index high is greater than or equal to the pivot. If that is the case, we will set high equal to high minus 1 by using the minus equals operator, which will handle both the assignment and decrementing of the variable. Then comes another while loop. It will also iterate while low is less than or equal to high, but will have an AND condition of when elements at index low is less than or equal to the pivot. If that is the case, we will set low equal to low plus 1 by using the plus equals operator, which will handle both the assignment and incrementing of the variable. Next, we will have an if statement that will check if low is less than or equal to high. If that is the case, we will swap the items for elements at index low and element at index high. Else, we will break from the while loop. Outside of the while loop, we need to swap the element at index left with the element at index high. Then we will return high. Okay, that wraps up the partition function. Next, we need to write the function that is actually going to perform the quicksort. As you will see in a moment, the quicksort function is recursive, meaning that it calls itself from within its own function body as it progresses towards a base case. We will use Python's def keyword to name our function quicksort. Our function will take in the same 3 parameters as the partition function that we just wrote, elements, left, and right. Inside of this function we will check if left is greater than or equal to right. If that is the case, then we will return from the function. After that we will set p equal to a call to our partition function, passing in elements, left, and right. Then we will call quicksort recursively, passing in elements, left, and p minus 1. Next, we will call quicksort again, passing in elements, p plus 1, and right. That completes our quicksort function. We will create a list named elements with the values 9, 1, 2, 0, 10, and 3. Then we will call quicksort and pass in elements, 0, and the length of elements minus 1. Finally, we will print out elements. When we run the code, you will notice that the output is a sorted list. Great work! You now know how to implement the quicksort algorithm in Python. In the next lecture, we will learn about the merge sort and how to implement it in Python.